This lab is experiment 12, solubility and solutions. There are 3 sections in this lab. We're going to discuss one section and do it, and discuss another section and do it. Okay, the first section is saturated solutions. We are going to make saturated solutions. A solution is saturated when the maximum amount of solute is dissolved in the solvent. So, saturated solution, we are actually, when we are making this, we are actually testing the solubility of a substance in solvent. Okay? The substance in this lab, we're going to use potassium nitrate as the solvent. We're going to use water as the solvent. And this is how we're going to do it. Okay? We will keep adding potassium nitrate to a fixed amount of water until it doesn't dissolve. By that time, a saturated solution is made. We know that the solubility of a substance is related to temperature. When temperature goes higher, solubility increases. Therefore, we will perform the lab first at room temperature. We'll keep adding potassium nitrate to water until it doesn't dissolve at room temperature. Then we will increase the temperature to 50 degrees Celsius. By that time, we will keep adding additional potassium nitrate to it until it doesn't dissolve anymore. By doing that, we observe the solubility of potassium nitrate in water at different temperatures. After that, we're going to cool the solution down and observe if the potassium nitrate will come out, precipitate out from the solution at low temperature. Okay? When we do that, you have to make your observation, take a record of your observations and explain your observations. Since we're going to use a water bath for 50 degrees Celsius, so we may want to set up the water bath first. Okay, I will let it heating here. Leave the thermometer here. We'll start the other part of the experiment. Now, we're gonna have 10 mils of distilled water. Okay, that's about 10 milliliter. Pour it into a test tube. We need to know the temperature of it. 22.0. Okay, 22.0 degree. Record it on your report sheet, line number 1. 22.0 degrees Celsius. Now we're going to add potassium nitrate in portions of 2 grams. And we're going to measure potassium nitrate, about 2 grams. This is potassium nitrate. Okay, 2.385 grams. You do not put this on your line 2 yet, but you'll take a record of this mass, okay, somewhere on your notes. Okay, 2.385 grams. We're gonna pour this into the test tube. and we'll shake it. We will stir it to see if it all dissolves. If it all dissolves, we'll keep adding potassium nitrate. If it doesn't, basically the solution is saturated with 2.385 grams of potassium nitrate at room temperature. We'll give it some time. We'll keep shaking, stirring. Now I have been stirring this for about 5 minutes. Looks like it's all dissolved. There's a little bit of particles there. I don't know if you guys can see that, but I know that it's gonna dissolve. Oh, it's all gone. It's all dissolved. Good. I'll add another portion of potassium nitrate, about 2 grams. I'm gonna measure another portion. $2.183 grams. Take a record. The one we just added was 2.385. Now we add another 2.183 grams. I keep doing the same thing like I did for the first addition. We'll give it a little more time, maybe this time even longer than 5 minutes. We'll see. Now I have been stirring this for I'd say more than 10 minutes. And as you can see, there is a significant amount of solid potassium nitrate that is not dissolved. I don't think it's going to dissolve anymore. I've been waiting here, stirring, shaking. Nothing happens. So that's it. I believe this solution right now is saturated at room temperature. Okay? We have added the maximum amount of potassium nitrate that can be dissolved in this 10 mils of water at room temperature. You need to add the two measurements, 2.385 and 2.183. Add those two numbers together and put it on line number 2, mass of potassium nitrate dissolved. Okay, now we're gonna put this test tube with potassium nitrate undissolved in it, put it in the water bath. Let's check the temperature. 50, 51-ish. That's good. Okay, let's put it in and let's stay there for some time. Let's see if it dissolves. Okay, it's all dissolved. Let's add another portion of potassium nitrate to it. .173. .173. Let's see if it dissolves. Okay, there might be a tiny bit there, but I suppose it's all gone now. One couple particles. I'll add another portion. Okay, looks like it's all dissolved now. 2.244. 2.244 grams. The last one is 2.173. This one is 2.244. Let's give it some time again. Well, again, it is more than 10 minutes. As you can see, there's a portion of potassium nitrate, significant amount of potassium nitrate that is not dissolving. Okay, I will stop here. Okay, looks like the solution is saturated at 50 degrees Celsius. Again, take a record of the amount of potassium nitrate added at 50 degrees Celsius. It is the sum of 2.173 and 2.244. You add these two numbers together, put it on line number 4. Okay. Line number 2 is the total amount added at 22 degrees Celsius. And line number 3 is the additional amount of potassium nitrate added at 50 degrees Celsius. Totally, now the total mass of potassium nitrate in the test tube is the sum of line 2 and line 3. You add them together, put it on line 4. Okay, let's do the next part of this experiment. What we're going to do, I'm going to raise the temperature of the hot plate, the water bath, put it in it, try to dissolve all the potassium nitrate in it. Then I'm going to bring it out, cool it down, and observe first at what temperature the crystal will come out. Okay, when temperature goes lower, solubility decreases. Then the amount that was dissolved at 50 degrees Celsius or higher temperature later on cannot be dissolved anymore at lower temperature. So solid will start to come out. We will record the temperature when you see the first crystal coming out from the solution. You're going to take a record of that. After that, we're going to put it in the ice bath and observe what happened. You need to observe, write down your observation and to explain why you observed what happened. Okay, I'm going to increase the heating. Okay, make the water bath at higher temperature, but do not let it exceed to 60 degrees Celsius. When temperature is too high, it's hard for you to cool it down later on. Okay. Now all the potassium nitrate has been dissolved. They're all gone. I actually has removed the heating setup. Okay, I'm gonna leave it here. I'm gonna leave it here to let it cool down. And I'm going to put a thermometer in here. I'm going to observe it when the first crystal is coming out from it. When the first crystal is coming out from it, I'm going to take a record of the temperature to see at what temperature the first crystal will come out. Look at that. I don't know if you can see the crystals, but at the bottom of the thermometer, there are some tiny crystals coming out. I hope you can see it. I'm not sure, but I can see it clearly. Okay, let's take a look at the temperature. 52.0 degrees Celsius. That's the temperature when the first crystals came out. You'll take a record of this on your report sheet, line number 5. Record down the temperature, 52.0 degrees Celsius. When the first crystal is coming out, you write down that observation. Now let's put it into an ice bath. some ice bath here. I'm gonna put the solution into it. Let's see what happens. Wow, look at that. Crystals, this is less than 20 seconds, I would say. Significant amount of crystals coming out, okay? So lots of crystals coming out from the solution. And that is because when temperature drops to 0 degrees Celsius in an ice bath, the solubility of potassium nitrate decreases significantly. So lots of solid coming out. Okay, you write it down again, explain it. We actually kind of explained it already. So take a record on line 5, write down what you observed when you put it into an ice bath, and put your explanation under that section. The second portion of this experiment is electrical conductivity test. Many substances, when they're dissolved in water, they break into ions. And ions are charged particles. They can conduct electricity. We call them electrolyte. Okay? Some substances are strong electrolyte. Some substances are weak electrolyte. And some substances do not break into ions in water. They will not conduct electricity. We call them non-electrolyte. Okay, so we have this little conductivity indicator equipment that we use. Every time we use it or after we use it, we will rinse it with distilled water. We will wipe it with tissue, and we'll dip it into a solution. Okay. On top of this equipment, there are 2 buttons that label as high and low. One is high, one is low. Okay, and there are indicator bulbs here. You dip it into solution. You first press high, keep pressing it to see if any bulb will light up. If nothing lights up, you press low and to see if any light bulbs will light up. Okay, high means better conductivity, better electrolyte. Low means weaker. Non-electrolytes, when none of the bulbs will be lit up, either at high or low, okay? Okay, before we perform this experiment, we have 10 solutions, but these 10 solutions are different from the ones in the lab manual. So let's take a record of the solutions we're gonna use, okay? Go to your report sheet, find the solution, and write down the solution we're gonna use. It may be different from the solutions on your report sheet, okay? We do have distilled water, tap water. We do not use 1 m sodium chloride. We use 0.1 and 0.001 sodium chloride. Okay, sodium chloride will have 0.1 m and 0.001 m. Sucrose, we have 0.1 and 0.01. 0.1 and 0.01. Okay. Hydrochloric acid, we have 0.01 molarity and 0.0001. 3 zeros after decimal. 0.0001 molarity HCl. The last one, glacial acetic acid. We have acetic acid and 0.1 molarity acetic acid. They are the same as the ones in the lab manual. Okay, let's start testing. This is relatively easier. I'm gonna open the jar. This is distilled water. It's the distilled water. I'm gonna rinse it. Wipe it. Dip it into the solution. High, nothing light up. Low, 8. Low, 8. So take a record of distilled water. Low, 8. Now next one. Tap water. High 4. High 4. Okay? Take a record. High 4 is the tap water. Tap water has some electrolyte, very small amount of electrolyte in it. Okay? So looks like there's some other things in it that can conduct electricity. Next one, 0.1 molarity sodium chloride. High 6, 0.1 molarity sodium chloride. High 6. I'm sorry. High 6. Next one, 0.001 0.001 sodium chloride. High 4. 3, 4. High 3. Okay. Next one, 0.1 molarity sucrose. 0.1 molarity sucrose. High, nothing. Low, 9. Low 9. That's 0.1 sucrose, low 9. Next, 0.01 sucrose. High, nothing. Low, 9 again. Next, 0.01 hydrochloric acid, HCl. High, wow, high 10, it goes to high 10, 7, 8, 9. Let me check. Wow, high 10, it goes to high 10. Next, we're almost done. Next, 0.0001 HCl. Let's go high 3. Next, acetic acid. Oh, it smells. High, nothing. Low, 1. Low 1. Acetic acid, low 1. Now is the last one. The last one of this section. Point 1 acetic acid. High 7. Oh, okay. High 7. High 7. All right, we're done. Section number 3, the third part of this experiment, is to test the solubility of 4 different substances in 4 different solvents. The 4 different substances we use: salt, it is in the lab manual; sugar, it is in the lab manual, the sucrose; naphthalene in the lab manual. This number 4 we use different in the lab manual. It says iodine. We don't use iodine. We use potassium acetate. So we're going to test these 4 different solids in 4 different solvents. So 4 times 4, we need 16 test tubes. I have put 16 test tubes here, divided them into 4 groups. Each group is 4. I label them from 1 to 4. Okay. Inside each test tube, to save time, I already put 4 mils of a solvent. The 4 different kind of solvents we're going to use: number 1 is water, number 2 is ethanol, number 3 is acetone, number 4 is petroleum ether. Okay, I have 4 mils of each in them already. What I need to do is to each one of them, I'm going to add 0.05 grams of this. You don't have to measure 0.05 grams. I know what it is, so I kind of measure it ahead of time. So I'm going to add a little bit. I'm going to start from the first group. I'm going to test sodium chloride. I'm going to add 0.05 grams of sodium chloride in here. If the sodium chloride all dissolves, we say it is soluble. Okay? If you see, okay, clearly it dissolved some, but not all of them is gone, that is slightly soluble. And if you see, oh, maybe not, it's so hard to tell. If it is so hard to tell, that is insoluble. So you're going to write either S for soluble, SS for slightly soluble, or I for insoluble in that table on the report sheet. So let's start from sodium chloride. I will try my best to add the same amount of sodium chloride to it. Okay, I know how much is about 0.05 grams. Let me show you how much it's going to be. This is about 0.05 grams. It's only at the tip of the spatula. Okay, that's about 0.05 grams. Okay. I'm going to shake them up. Maybe one at a time. It is all dissolved. There's no solid in it anymore. In water, it is soluble. Ethanol, clearly, you still see some solid in it. But to me, maybe you guys don't see it like I do. To me, there is clearly some of them is dissolved. The amount left is clearly less than what I put in. So slightly soluble. Nothing got changed. Nothing. Okay. Insoluble, insoluble. So table salt in water soluble, ethanol slightly soluble, acetone insoluble, petroleum ether insoluble. Okay, now I'm gonna do the same experiment for table sugar. Very, very similar to the case of sodium chloride. Very, very similar. Soluble water, slightly soluble ethanol, insoluble in acetone, and petroleum ether. Naphthalene, needless to say, insoluble. It doesn't even mix with water. Okay, a lot of them stay on top of the solution. It doesn't even go down. Okay, doesn't mix with water. Insoluble. The case of ethanol. Okay, I'm not sure if you can see it in the video. I can see clearly there are substances going up from the surface of the solid getting dissolved in ethanol. Let's give it some time, leave these three here for some time. Let's move on to the fourth one, number 4, potassium acetate. All right, now we have finished shaking all of this. Again, now we're looking at naphthalene in water. As you can see, the solids are still in there, nothing dissolved, insoluble. naphthalene in ethanol, well, there might be a small, very, very tiny bit there, okay, but it's almost all gone. There's very, very small amount still at the bottom, a few particles. I'll call it soluble. Oh, this is in number 3, naphthalene, in number 3, acetone, in number 4, petroleum ether, clearly, all dissolved, soluble, soluble. So naphthalene in water, insoluble, ethanol, soluble, acetone, soluble, petroleum ether, soluble. Now the last group, I already did this, potassium acetate in water, all dissolved, soluble. In ethanol, there are a few particles at the bottom. If you don't look at it carefully, you may miss it. So very, very small particles at the bottom, soluble. Look at that. That is in potassium acetate in acetone, insoluble. And potassium acetate in petroleum ether, insoluble. Okay, that's it. That's all we have for this lab. Okay, finish the lab report and see you next time.